It is the afternoon of October 23rd, 1930, on the unfinished deck of the Sydney Harbour Bridge. Boilermaker Vincent Kelly is driving rivets nearly 180 feet above the harbour when his foot slips. There is no harness, no net. Below him, cold water, ferry traffic, and a bridge that has already tested every one of its engineers' calculations. As Kelly tips backward into open air, one question hangs over the whole work site. Will the harbour take another life? And can a project already stretched this thin survive the year still ahead of it? By the 1920s, Sydney's harbour had become the city's biggest obstacle. Ferries hauled tens of thousands of commuters across the water every day, and the fast-growing North Shore had no fixed link to the business district at all. Engineer John Bradfield had pushed for a bridge since before the First World War. In 1924, the British firm Dorman, Long & Company won the contract to build his design, an arch spanning 1,650 feet, wide enough for 8 lanes of road and rail, and among the largest steel arch bridges ever attempted. But the arch had to be built as 2 separate halves, growing out over open water from opposite shores, with nothing connecting them until the very end. What happens if 2 half arches, each hanging in midair for years, do not meet in the middle? The man now falling toward the harbour had learned his trade the hard way. Vincent Kelly, born in Ireland, fought in the trenches in France during the First World War before returning to Sydney to finish his boilermaker's apprenticeship. By 1930, he was one of hundreds of riveters working the bridge deck. Men who spent their days passing rivets, glowing white-hot, from furnace to gun, hundreds of feet above the water. Kelly also happened to be an experienced diver. That detail was about to matter. The bridge's steel was fabricated at workshops on the harbour's North Shore, then floated out on barges and lifted into place. Riveting itself required a 4-man team. A cooker heated each rivet white-hot in a furnace, then threw it, by hand, to a catcher, who passed it to a holder-up, bracing the far side while a boilermaker like Kelly hammered it home with a pneumatic gun. Nearly 6 million rivets went into the bridge this way. 1 team, 1 throw, 1 hammer stroke at a time. Roughly 80% of the steel itself arrived by ship from mills in England. The rest was rolled locally at steelworks in Newcastle, New South Wales. The greater risk was in the arch itself. Each half was cantilevered out from its own shore. Held back by 128 steel cables anchored in tunnels cut into solid rock. By the time the 2 halves approached each other, each cantilever stretched more than 650 feet into open air, carrying over 13,000 tons of steel, with nothing underneath it but cable tension. Engineers calculated a gap of roughly 42 inches would remain at the centre once both arches were complete. If a single calculation was wrong, if the steel stretched more than predicted, or the cables held less than expected, the halves would not simply fail to meet on their own. Forcing them together would then take a far more dangerous correction, hundreds of feet above the water. On August 19, 1930, engineers began the final stage, releasing the 128 cables on each side, 3 inches of tension at a time, to lower the half arches into alignment. It took most of the day. Then, as the afternoon cooled toward evening, the steel itself began working against them, contracting faster than the cables could be released, pulling the 2 halves apart again just as they were closing. Through the evening, under electric floodlight, the crews kept releasing cable. Just before 10 that night, the 2 halves touched, and a locking pin dropped into place. For the first time, the Sydney Harbour Bridge held itself up. Lifting that steel in the first place required machines built specifically for the job. 2 580-ton electric creeper cranes, each capable of hoisting 122 tons of prefabricated truss that climbed the arch as it grew, rather than depending on scaffolding across a working harbour. Behind them stood 28 volumes of engineering calculations. worked out by hand years before a single rivet was driven, governing every cable, every joint, every degree the design allowed for error. None of this made the work safe. Over nearly a decade of construction, 16 men died on the bridge, not in one disaster, but one at a time. A fall from a girder here, a dropped load there, spread across years of routine, dangerous labour. There were no harnesses. There was most days no net. By the time Kelly lost his footing in October 1930, the crews already knew exactly what the harbour could take from them. Their names are recorded today at the bridge's pylon lookout, a permanent record of what the job actually cost. Kelly did not simply fall. In the seconds before he hit the water, the same instincts that had made him a skilled diver took over. He twisted his body through a somersault and speared in feet first, cutting cleanly through the surface instead of slamming flat against it. He came up with a few cracked ribs and a bad case of shock, and was back on the job less than 2 weeks later. His employer gave him a medal. His workmates just called him lucky. The bridge did more than connect two shores. Rising through the worst years of the Great Depression, it gave work to well over 1,000 men when work of any kind was scarce. Its 4 granite pylons, quarried nearly 200 miles south and hauled to the site by ship, carry no structural load at all. The arch does that work alone. The pylons exist purely for weight in the visual sense, a monument built to look as permanent as the bridge beneath it actually was. Stonemasons were even brought in from Scotland to shape that granite, since Australia had no workforce experienced in cutting stone at this scale. Sydneysiders came to call the finished structure the coat hanger, a nickname it has kept ever since. The Sydney Harbour Bridge opened on March 19, 1932. Its load capacity tested beforehand, with 96 steam locomotives lined up nose to tail across its rails. Within a few years, the ferries that had once carried some 40 million passengers a year across the harbour saw that number fall by more than half, as commuters simply drove or rode across the bridge instead. Nearly a century later, the bridge still carries traffic across the same stretch of water it was built to close. The same arch, the same rivets, the same cable tension long since resolved into steel. The gap that worried engineers for years came down to a few dozen cables and a race against falling temperature on one August evening. It closed by inches, released a few at a time by men who had already spent years finding out exactly how much the bridge, and the harbour below it, would tolerate. These systems shaped the world quietly. If you'd like to see more of them preserved, consider subscribing, and tell us, which forgotten craft should we document next?